Hi, welcome to Nomis Academy. In this video, we are going to learn how to find the range values of x for which a particular function is increasing or decreasing. In this video, I'm going to explain what an increasing and a decreasing function is. Firstly, if y equals f of x, which is a function, is increasing when given a particular value or interval of x, then dy dx is greater than 0. So whenever f of x is increasing in a particular interval, then dy dx, that is the derivative of that function, is greater than 0. Also, if y equals f of x is decreasing, then the derivative dy dx is less than 0. So whenever a function is decreasing, then the derivative, which is dy dx at a particular interval, is less than 0. Let's take the first example. Example 1. Find the range of values of x for which x raised to the power of 2 minus 3x is increasing. Okay, in this question, we would like to know the range values of x for which this function is increasing. Solution. Let y equal to x squared minus 3x. Alright, so since the function is increasing, we write the y, the x is equal to, you take the derivative of the function, derivative of x squared is 2x, and then derivative of minus 3x is minus 3. Since y equal to x squared minus 3x is increasing, then dy over dx must be greater than 0. So it means that this value, 2x minus 3, must be greater than 0, in as much as the function is an increasing function. So we would like to know the range values of x for which this particular function is increasing. So let's simplify this. 2x greater than 3. And then when you divide both sides by 2, we have x greater than 3 over 2. So from s greater than x 3 all over 2 is the point at which the function is increasing. So the range values from 3 over 2 is the point where the function is increasing. Let's take the second example. Example 2. Find the range of values of x. Okay, let me take it down. Sorry, let me take it down a little so that you can see what I'm writing. Take it down. Okay, example 2. Find the range of values of x for which x cubed all over 3 minus x squared all over 2 minus 2x is increasing. Alright, in this problem, we would like to find out the range values of x for which this particular function is increasing. Okay, let's quickly go to the solution. let y equal to x cubed all over 3 minus x squared all over 2 minus 2x. Alright, so I'm going to find the y dx of the function, that is the derivative of the function. So dy over dx is equal to, now let's differentiate this, and that will be what? 3x squared all over 3 minus, differentiate this, that will be what? 2x raised all over 2. And then minus, differentiate 2x, you have 2. So we have dy over dx equal to, this cancel this, 3 cancel 3, we have x squared, minus 2 cancel 2, we have x, minus 2. So this is the function. For this function to be an increasing function, then dy dx must equal to 0, must be greater than 0. So if y equal to x cubed over 3 minus x squared over 2 minus 2x is increasing, then dy over dx is greater than 0. Okay, so it means that I'm going to equate the derivative, or I will equate the derivative to 0. So that will be x squared minus x minus 2 greater than 0. So I'm going to find the point at which the function is increasing. Now let's simplify this. This is a quadratic expression. So we are going to solve it. We have x squared minus x or plus x minus 2x greater than, minus 2 greater than 0. So when you use factorization method, you factorize the quadratic equation, then keep the first two and simplify what is common. Here we have x plus 1, and then here we have minus 2x plus 1 greater than 0. So the two terms we have are x plus 1 and x minus 2 greater than 0. So at the point x plus 1 greater than 0 or x minus 2 greater than 0. So let me clean this other side so that you can see the solution. Alright, so at this point, x is greater than minus 1 or x is greater than 2. At these two regions, or these points, are the points where the function is increasing. For a better understanding, I would like to take you to the graph to see exactly how the function is increasing. When you have your graph in this form, and this is the x-axis, and this is the y-axis. So at the point where x is minus 1, so let's take it to be minus 1, and then at the point where x is 2, so let's call here 1 and call here 2, call here minus 1 and call here minus 2. Alright, so when you draw the curve, something like this, it passes through x minus 1, have it this way, and then up to 2. So you can see at this region, the function is increasing, and then at this region, the function is increasing. So I don't need to go down because at this point or this region, the function is decreasing. Then at this point, the function is increasing. So at the point where x is greater than 1 and x greater than 2, the function is increasing. Alright, thank you for watching. See you next time. Bye.